Hi, and welcome to another video, another lesson actually. And we are gonna look at diagonal surfaces. So all the questions we've done so far, the surface has been horizontal, right? So for example, we've had situations where you have a flat piece of land. Yep. And there is an object or particle on top and it's moving. Um, the land has always been horizontal flat. Now we want to move to situations where the actual surface or the land is diagonal, right? So, for example, um, this type of situation here, right? There's a diagonal land with a surface on with an object lying on top. Now that creates slight complexity because your forces will then have to be diagonal, right? So you can have situations like this, or you can have, sloping downwards with an object like that. So multiple scenarios. Um, but this is slightly more difficult than a flat surface, right? So what we're going to look at is the different types of forces that are um, on an object. Yeah. So let's say this is an object of 5 kg, for example. Yeah, it's lying on a diagonal surface. Now think of what forces are acting on this object. So we always start with the, apologies for that. We always start with the weight force, right? Now, weight is always acting downwards. So you will have a weight force which is vertically down. Okay. Now, weight is always mg. In this case, the mass is 5. Gravity is 10 for Cambridge. So 5 times 10 is 50 newtons acting downwards. I'm just going to remove the n just to make it easier looking. Right, so 50 newtons. So the weight is always acting vertically down. And you also have the normal reaction force. Now remember, the normal reaction is always right angled to the surface, right? So if your surface was like that, your normal force would be like that, right angle, right? Now our surface is diagonal. So if we want a right angle force, we are looking at this direction. Okay. Now we want this to act at the surface. So now this will usually act in this way, uh, usually in the center of the object. So going like that. Okay. This will be your um, reaction force. Okay, so these two forces will always be present um, on an object or particle which is on a diagonal surface. And there will be also other forces which um, can be present depending on what the question says. So if the question says the block is being pushed upwards, right, then you will have a pushing force. Okay, so completely depends on what the question is asking. Okay, but the two forces which are always present are the weight and the reaction. Okay. Now, one thing that we will have in these questions is we want all the forces to be in either two directions. Okay, so we want either the forces to be in the direction of the surface. Trying to get a red one. Right. So we want all forces to be either like this direction or right angle, which is this direction. Okay. Now, if you look at the weight, right, the weight is not in any of these directions because the weight is vertically down. So we have an issue here where we want to convert the weight into one of these directions. The reason we want all forces to be like this is because when we do F equals ma, we only have two directions that we work with. We can't have any other random directions. Okay? So the general rule is for F equals ma, you do the direction of the slope, which is like that, and perpendicular to the slope, which is like that. Okay, so same as what we have here. When we had a flat surface like that, we had in the direction of the surface and perpendicular to the surface. So it was exact same concept. Over here, because the surface is diagonal, it's slightly more complicated, but it gets easier as we go along. Okay, so focusing on the weight, because the weight is vertical and we want all our forces to be in these two directions, we first need to convert the weight. Okay, so just before we get on to that now, we are using F equals ma again for these type of questions, and it's important that you know which directions to use the F equals ma equation. Right, now, first let's look at a situation where a particle is moving up the slope, which means it's moving in this direction. Okay, now generally up the slope means up minus down equals ma. Yeah, so what that means is up minus down equals ma in this context, right? Up means diagonally upwards, down means diagonally downwards. If the particle is moving down the slope, that means down minus up equals ma. So same concept as we had before, but we are using diagonal uh, directions here, right? So down minus up equals ma. Right, now, if you look at the right-hand side, it's the same thing. We've just inverted the slope. Okay, the slope is just opposite reflected. But again, same concept. Moving up means up minus down equals ma. Okay, now in this case, going up means like that, right? So up minus going down means that way, right? And if you're moving down, that means down minus up equals ma. Yeah, so exactly same concept. It's just slightly um, different direction, which we will get used to. Okay, once again, the problem here is the weight, because the weight is always in this direction, vertical. Okay, so the problem with the weight is it's neither in this direction or this direction. So first we are going to convert the weight and then use F equals ma. Okay, now how do we convert the weight into one of these directions? Right, so let's say there's a particle here of m kg. Okay, so you will have weight going vertically down like that. Okay, so weight is mg, so let's just label this mg for now. Okay. Now we want the diagonal direction of the weight. We don't want the vertical one, right? Now, what I'm gonna do here is, just for sake of argument, I'm gonna show you how this works, right? So let's just pretend the weight is over here, mg. Okay, now if you look carefully, this would be 90 degrees, right angle. Okay, this would be angles in a triangle add up to 180. So 180 minus 90 minus theta, right? Which gives you 90 minus theta. Okay, so this angle here is 90 minus theta. Okay, now the weight, we want two directions. One is right angle to the slope, okay, and one in the direction of the slope, like that. So we want to convert the weight into these two directions. Okay, now, the way we do that is um, we have this angle here, which is 90 minus theta. Now, if you look carefully, this will be a right angle. Okay, that's a right angle. Now, if I want to calculate the angle which is over here, yeah, I will do the right angle I just made, okay, minus the blue angle over here, right? So I will do the right angle, red one is 90, minus the blue angle, which I have over here, 90 minus theta. Okay. Now, if you open this up, this will give you 90 minus 90 plus theta, okay? Because minus minus is plus. That gives you theta. Right now, what that's telling you is this angle here, the green one, is also theta. That's theta, they're both the same. Okay, now using this, we can calculate the two weight components, right? So let me just move this. We had mg. This was mg, right? Now, we have two components. One is opposite, one is adjacent. So this is opposite the angle. So that's mg sine theta, okay? And the one which is adjacent will be mg cos theta. Right. Now, you don't need to know how I got this. This is just proof, just so you have an idea of what's happening. If this looks complicated, don't worry. What's important is that you know whenever we have a weight on a slope, okay, you will have the original weight, which is mg, okay, and there will be two components of the weight, okay. One will be at a right angle. One is at a right angle and one is in the direction, okay. So what's important is that the opposite to the angle is mg sine theta, and the adjacent is mg cos theta. Okay. And make sure you get the directions correct as well. So we're starting here and ending there. Okay. So this is what you need to know, how the weight converts into two components. And I'll show you more in the next few slides. All right. So if you haven't copied it down, I've made a drawing here. Right. So this is the original weight, mg, and the two components are mg sine, because that's the opposite, and mg cos. Right. Now, before we use that in questions, Trust me, it will get much easier when we start using it. But just before we do that, there are two types of slopes. One is smooth and one is rough. Okay. Now, smooth means there is no friction, and rough means there will be friction, which you need to take into account, right? But we will cover friction and rough surfaces later on. At the moment, we will just focus on smooth. Right. So let's look at one example here. If you can pause, write this down, and then resume again. So there is a 5 kg particle placed on a smooth slope, which means no friction. Okay. Um, it says find the acceleration and then find the reaction force. Okay. So what it's assuming is you will place the particle on the slope and it will then move down, right? Because the slope is going downwards. But first we need to get the forces right. Okay, so we have the weight force, which is mg. Okay, this is the weight force. This will be mg. Right, so 5 times, if you're doing Cambridge, G is 10. So 5 times 10 is 50. If you're doing EdXL, use 9.8 as gravity. But Cambridge, 5 times 10, 50. And so that's the weight force. Now, we don't want the vertical. We want all forces to be in either this direction or this direction, right? So we need to convert the weight into our two direction forces. So let's use a straight line. So we want one force, make it thicker. So we want one force like this and another force going in this direction. Right, so then we have both the weight in these directions. Okay, now the vertical weight is 50. The two components will be, now remember, if this is theta, this is also theta. So because that was 30, this is also 30. This is opposite. Okay, so this component will be 50 sine 30. Actually, let's make it diagonal in black. This is 50 sine 30, and this will be 50 cos 30 because that's adjacent. Okay, and once we've done that, we have the reaction force, which goes like that. Okay, now these are all the forces which are acting on the particle at the moment. Now we know that the particle will go down, right? Because the slope is moving downwards or it's steeping down, right? So our direction will be down. Okay. Now, when we do F equals ma, we need to do down minus up equals ma. Because this is a slope, we will have down going this way and up going this way. Okay. Now, which forces are going down? We have this force, which is 50 sine 30. Okay. Which forces are going up? None. So that's 0. equals to ma. Now m is 5, and acceleration we do not know, so let's just label that a. And doing this in the calculator, so 50 sine 30 is 25, equals to 5a, and a is equal to 25 divided by 5, which gives you 5 ms minus 2. Again, you don't need to write the units. You should be fine if you just write 5. Okay, now this was part A. Now let's move to part B. Part B, they're asking you for the reaction force. Okay, now when we do the reaction, we are looking at this direction. Yeah. Now the particle is not moving in this direction. It's only moving like that, like this. Okay. So in this direction, where the reaction force is, your acceleration is 0. Okay, because the particle is not moving in this specific direction. So it doesn't matter if you do up minus down or down minus up. Okay. I will just do up minus down equals ma. Okay. Now in this direction, what's going up? So obviously your reaction force is going up in that direction. Okay, so going up is the reaction. Going down is this force over here, 50 cos 30 in this direction. Right. And this is equal to ma. M is 5. Acceleration in this direction is obviously 0. And if we were to solve this, r is equal to 50 cos 30. Right, which if you do in your calculator, should give you .3. Right. Now moving on to the next one. Again, pause the video and write it down, and then we will go through it. Okay, so first thing you do when you get worded question is look at the surface, what kind of surface it is, right? So they're telling you a particle is pushed up a slope inclined at 30 degree to the horizontal. So this is the key bit which tells you what the surface is. Is it flat or is it diagonal? Okay, so they're telling you the surface is diagonal, okay? And the surface is inclined at 30 degrees. Right, so this is the surface that we have. A particle is 3 kg, so it's over here. And particle is pushed. Okay, so let's move this. The particle is pushed by a 40 Newton force, which acts parallel to the slope. Again, this is the key point. Okay, now parallel to the slope means same direction, right? So if our force is like this, sorry, if our slope is like this, the force will also be in the same direction. Okay. Now, what they're telling you is there is a 40 Newton force which is pushing the particle. Okay. And the force is parallel to the slope, which means it's going like that. Okay. So let's just make that a bit more thinner. So this is your 40 Newton, which is pushing the slope upwards. Okay. Now it's very important they told you that it's parallel to the slope. Okay. Because if it wasn't parallel, it can be applied in any direction, right? You can have a 40 Newton force which is going like that, or a 40 Newton force which is going like this. So unless you know what direction the force is, then it's very, very difficult to draw it. Okay, so they've told you it's a 40 Newton force, which is parallel to the slope, which means it's in the same direction as the slope. So we've got that down. The particle faces a resistance of 8 newtons. Okay, now remember the resistance is always opposite to the motion. Okay, now the particle is traveling this way. Yeah. This is the direction of motion. Okay. Resistance would be exactly opposite direction, which means this way. This would be your resistance. Okay. So your resistance will be going this way and it will be 8 newtons. So these are the two forces they've given you. The other forces you need to plot yourself. One is the reaction force, which is right angle to the surface. Okay. And the other is the weight. Now, weight is vertically downwards, which makes it mg. So 3 times 10 is 30. Again, if you're doing Edexcel, use 9.8. Okay, now we've got all the forces. The only problem is the weight is vertical. And once again, we want all our forces to be in this direction. Okay, either with the slope or perpendicular to the slope. So the weight, we need to convert that into two other forces. Okay, so it's just different color. Right, so for the weight, we will have one force in the perpendicular and another force in parallel to the slope. Okay, make sure you get the directions. So this way and this way. Okay, now the angle here is important. So we had the angle was 30, so this will also be 30. Okay. Um, now we have the opposite, right? The opposite is sine, so this will be 30 sine 30, and this will be 30 cos 30. Okay, this is always the rule for the weight. So we've got both the components of the weight sorted now. So once we've got everything, all the forces in this direction, then we can move on to F equals ma. Okay. Now the particle is being pushed up, as it says in the question, right? So we are going to be looking in this direction. Okay. Now, because the particle is being pushed up, we have to do up minus down equals ma, right? So everything going up minus everything going down equals ma. Okay, now first find the forces which are going up. So going up, we have this 40 force. Okay, and that's the only force going up, right? And which forces are going down? So obviously the 8 is going down. And if you look at this force here, 30 sine 30, that's also in this direction downwards. Okay, so two forces going down, 8 and 30 sine 30. Okay, so we combine these together, up minus down, equals MA. M is 3, and A we do not know. Right, now, let's try solving this. So 40 minus 8 plus 30 sine 30 will give you 23. Okay, so that gives you your acceleration, right? So fairly simple. Obviously, the weight is slightly complicated. So whenever you get this question, first make sure you get the weight two components always drawn on the diagram. And then once the other forces are done, you can start F equals ma. Okay? So slightly complicated when you start with, but once you've got the two weight components done, then it gets obviously a lot more easier. We're going to stop there. I've got 2, 3 more questions for you to try in the description. So try those, check your answers, and then the next video, we will go through a lot more complicated questions of this time. So we'll stop there. See you soon.